Welcome to the acceleration due to gravity, and as the title implies, we're going to look at the acceleration of a body when it's being acted upon by gravity. Now, the acceleration due to gravity is given the symbol g, little g, and when we're talking about this, we're going to ignore all forces acting on the body except gravity. Now, near the surface of the Earth, all bodies accelerate downward at a plus 9.8 meters per second square. That means their speed increases by 9.8 meters per second every second that they're falling. So starting from rest after 1 second, a body will have a speed of 9.8 meters per second. After 2 seconds, it will have a speed of 19.6 meters per second. Now, near the surface of the Earth, all bodies decelerate at minus 9.8 meters per second squared. And as we learned before, deceleration means something is slowing down. So the bodies slow by 9.8 meters per second every second that they're rising or going upwards away from the Earth. So starting at 19.6 meters per second, after 1 second, the body slows to 9.8 meters per second. And after 2 seconds, it has a speed of 0. And free fall is when a body is acting under the influence of gravity only, or gravity is the only force acting on the body. Let's take a look at a quick example here. A wrench falls from a roof. When it passes your window, it has a speed of 3.1 meters per second. Find its speed 3.5 seconds later. I'm going to use the equation that we learned in the section on acceleration. And in this case, the acceleration is the acceleration due to gravity, so it is the value of g, 3.1 meters per second, plus 9.8 meters per second squared, times 3.5 seconds. Doing our calculations, gives us a final velocity, v2, of 37.4 meters per second. All right, we're going to take a look at a second example, and this one is a case where we have a ball kicked upward against the force of gravity. A ball is kicked with an initial vertical velocity of 24.5 meters per second. How long until it stops rising? And note that the ball stops rising when its vertical velocity is 0. So the ball goes up and slows until it comes to 0 speed. Starting out with our basic equation, v2 equals v1 plus at, knowing that v2 is equal to v1. In this case, a is g, so we have times time. v2 is 0 meters per second. v1, 24.5 meters per second, plus g, which is a minus 9.8 meters per second squared times t. Don't forget, the ball is rising, so it's slowing down or decelerating, and the rate of deceleration is 9.8 meters per second squared. Go about solving the equation. So we have t is equal to minus 24.5 meters per second divided by minus 9.8 meters per second squared, giving us a time of 2.5 seconds. And I know you understand this, but a negative divided by a negative is a positive. Okay, one more item to cover, and that is terminal velocity. Terminal velocity occurs when air resistance and buoyancy equal the force of gravity. So there is no net force acting on the body, so that it is not accelerating. It has reached its maximum speed.